I'll pick this next video up in the middle of the example. It was running a little long there. So I said that we are going to cancel out the p-values. We're going to be left with a 2 on the left side. And on the right side, I want to figure out what this base is. So in the parentheses, I'm going to go ahead and calculate that. It is 1 plus 0.08 over 12. And that is 1.00 with a 6 that repeats. That 7 is really a 6 repeating. They're rounding off there. So I'm going to go ahead and just write it as 1.006 with a bar over the 6. Then I know it's repeating. And then I've got a 12t power. Alright, to solve this equation, I need to again take the log of both sides. If you have a variable in an exponent, that's going to be the line of attack. Alright, so taking the log of both sides, you get to choose the base. I used the natural log in the previous example, so I think I'll use the common log in this one. It doesn't really matter what I use. So I'm going to take the common log of 2, and that's going to be equal to the common log of 1.006 repeated to the 12t power. Okay, so I've just applied a common log to both sides. I'm going to utilize one of the properties of logarithms. It was property number 9 on our list of 10 commandments. The one that says the exponent on the inside of a log comes out front as a coefficient. And so now I have log of 2 equals 12t times the log of 1.006 repeated. Alright, so now I'm going to try to solve for t. Well, t is being multiplied by two things, the 12 and this logarithm. So I might as well divide them out. Okay, so I can divide now both sides of this equation by 12 and by the log of 1.006 repeated. Try to squeeze that in there. Alright, so here again the 12s cancel, the logs cancel, and what I will be left with is a t value on that side, and the other side is this big combination of log of 2 divided by 12 log of 1.006 repeated. I go to my calculator and I'm going to calculate that. I'm going to put in log of 2 for the numerator. Now my denominator, I want to make sure that I surround the entire denominator in a set of parentheses, otherwise it will not put the log in the denominator. The order of operations will be wrong here. So you need the parentheses, and you do 12 times the log of 1.00, and then my repeated 6, here's what I'm going to do. Probably not the most accurate method, but I'm going to hit a bunch of 6s and then put the parenthesis on it. Now that just closed the parenthesis for the log. I need another parenthesis for the denominator. And when I hit enter, I'm going to get about 8.7 years. That's slightly off because I did round that 6 off at some point there, but that's okay. So let's go with about 8.7 years. Okay. Alright, so that should do it for the financial models. There's going to be quite a few examples where you're looking for the time or maybe looking for the rate. Just depends on the problem. But remember, you don't always need the initial investment. If you know that you're doing a doubling time or a tripling time, you would just write the final amount in terms of p, and the p's will cancel at that step, next step. Okay? All right, looks good.